Hey guys, so today's video is all about building RAG systems and applications using LangChain. I hope you guys know what is RAG, and you guys might also know what is LangChain. But if you don't know both, it's okay, not to worry. I'm going to explain both in the upcoming slides. So let's get started. Right. So this is the table of contents. This is what I'm going to talk about in this whole video. Building AI applications, how complex this journey is. We will talk about LLMs, I'll talk about chatbots, and then I'll talk about how LangChain came into existence. And then I'll talk about LangChain components, the modules, the growth of LangChain, the LangChain, where does LangChain sit in the GenAI dev stack if you're building generative AI applications and systems, right? And we will talk about the principles of LangChain, what LangChain basically, why people usually use LangChain, right? For what? Right, and then the advantages of LangChain, the some LangChain use cases, and getting started with LangChain, and then at the end I have a simple RAG demo to show you guys to show you that how you can use LangChain to build retrieval augmented generation applications, right? So let's get started. So yeah, I mean, building AI applications, as you can see the workflow image, right? So building AI applications is a very complex and multifaceted process that requires a lot of effort and skill set. And we already know that there's a lot of skills gap. The Gen AI, the Gen AI ecosystem is growing day by day. The new LLMs are coming up every day and we have moved from just naive RAG to advanced RAG to multimodal RAG to agentic RAG. The things are moving very fast, but there's a skills gap. And while building AI applications, while it starts from data collection, data pre-processing, data cleaning, and then the ensuring the models performance through hyperparameter tuning, evaluation, monitoring, and all these things add up an extra layer of challenges. And basically, building an AI app requires a lot of effort, a lot of challenges, and there's a skills gap. So yeah, I mean, you might say, hey, Pawan, LLMs are just enough to build AI applications. Actually, the answer is not. LLMs are not just enough. You need to have some kind of tools and frameworks that can basically help you build a very robust AI applications or RAG applications, right? But let's understand what exactly LLMs are actually made up of. They are made up of the data and then the architecture, the transformer architecture, the base architecture, what we call, and then some kind of training, right? That's how LLMs are made. And basically, they are just one piece of the puzzle while building a robust AI application, as you can see, right, in this image. Who will take care of the data management, right? Data ingestion, data processing, vector storage, and who will take care of the infrastructure, the integration layer, and then the application logic. So all these things are required to build a robust AI application. And if you say LLMs are just enough, then that's not the right answer because LLMs are just one piece of this whole puzzle while building robust AI applications, right? But you might say, hey, Pawan, there are chatbots already using LLMs. I understand there are chatbots already using LLMs, but it's all predefined, right? The input and output, everything is predefined, just like your the Alexa or Siri that you use at your home. Everything is pre-defined. The input and output, the engineers have fed something, and the same output comes out every time, right? While the chatbot shown here utilizes an LLM model for generating responses, it lacks the connected knowledge, right? There is no, what if you're working in a healthcare sector or a financial sector and you are building a chatbot, right? At that time, you need to have your own custom data so that the LLM can answer accordingly, that you can use the chatbot accordingly that suits your requirements. But here there is a lack of connected knowledge, right? So to build effective AI applications, it requires a comprehensive kind of AI frameworks and tools to and just beyond, beyond LLMs, and that is where basically LangChain comes in. So what happens when you're using chatbot using chat? You are building chatbot just using LLMs, right? So there are several critical limitations or challenges I can say. No, there is no access to current information, and these systems can't verify the accuracy of the responses. Who will say that the chatbot producing the responses, but how accurate they are, all right? And they lack access to the real time or custom data that you want to that you want to use in your that you want to use in your industry or the or where you're working, right? And they can't integrate with business systems or logic, right? You can't do much more with chatbots just using LLM. So these are some of the limitations, and that is where LangChain comes in, developed by Harrison Chase, and it came out in October 2022. Just started as open source library, right? So now LangChain is one of the most talked frameworks in the industry, right? While building LLM powered applications. So basically, LangChain streamlines the intermediate steps that we saw while building the applications to help you develop very data responsive applications, right? Powered by LLMs. So let's understand what exactly is the meaning of LangChain. We can split the word LangChain into two parts, that is Lang and chain. Lang, right? Language models. As you can see, GPT-4, we have Mistral model, we have Llama, we have Palm, we have Claude. And then the chain refers to the way of LangChain works, how the LangChain basically works. It's basically the concept of chaining together different components into workflows. So as you can see in the right side, the image workflow components, input, process, output. So that's how basically LangChain works. It combines the LLM's prompts and creates a proper workflow to help you solve a complex problem. Okay, that will basically help you build AI-powered applications, robust AI applications, and these are the LangChain components, and these add. This is what LangChain is made up of. Basically, the LangChain, the power of LangChain comes from these um, six modules or components that we can say. The first is LLMs. LangChain has the access to the LLMs, open source, closed source. It's LLM agnostic. And then indexes. You can index any type of data, document. There are document loaders. You can basically load PDF files, CSV files, and all that. And there is text splitters. There's a integration with vector stores and retrievers, right? And then the agents. You can leverage LLMs for reasoning to automate decision making, basically build agentic applications using LangChain. And then there is memory management. In LangChain, you can have short-term memory, long-term memory, chat history, right? All these things are possible using LangChain to maintain a chat history in your AI applications and all that. And then the chains that we saw in the previous slide, right? You can combine LLMs with modules to execute a sequence of functions, right? And basically create complex workflows using chains. And then the prompt templates, you can have reusable and customizable prompts for different scenarios, right? You can just build AI applications giving a proper prompt saying, hey, I don't know AI. I'm an 8-year-old. So explain me everything as if I understand, as if I'm 8-year-old. So you can customize the templates, or you can basically use the already available templates that LangChain has. So these are the main components of LangChain. And then this is again some in-depth components under LangChain components, right? The models, LLMs, you have chat models, you have text embedding models, and all that. And then the prompts, in that prompts, you can see prompt value, prompt templates, example selectors, output parsers, and all these things, and indexes. You have document loaders, text splitters, vector store integration, retrievers, and then memory short term, long term memory, chat history, and then the chain, LLM chain, prompt selector, and all that. And then the agents, you can basically do API calling, tool calling, agent executor, and all these things. Since LangChain has this first mover advantage in the AI frameworks, I just went to Google Trends to see how people are talking about this particular keyword LangChain. If you go to Google Trends and search for this, insert this keyword LangChain, this is how it is growing. I mean, a lot of people from last year, 2023, 2024, people are talking about it amazingly well. I mean, you can see the growth, right? No need to explain anything. So why not? Because every company now wants to be an AI company and want to build AI applications using these frameworks, and LangChain has the first more advantage, and that's why most of the folks are interested using LangChain and building their AI applications. And this is the growth of LangChain on GitHub. It is again growing up and above, and yeah, this is a simple LangChain timeline, right? As you can see, the first PR that came out in October 24, 2022, and then on October 25th, the first tweet kind of went viral by Harrison Chase. He says, introducing LangChain, a Python package aimed at helping build LLM applications through composability. Pip install LangChain. So such a simple but amazing tweet by Harrison Chase. And as you can see on Jan 18th, 2023, he posted about LangChain on Hacker News. It kind of went viral with a lot of upvotes, almost 372 points. And the first meetup happened on Feb 9, 2023. And then LangChain reached 10K stars in Feb 20th, 2023 in such a short period of time. And on April 4th, 2023, they reached 10 million benchmark. And April 13th, they reached 200 million valuation, right? And on July 28th, 2023, they came up with the Langsmith, the first managed service by LangChain, right? And on October 2nd, 2023, they reached almost 64K stars on GitHub and started having some enterprise clients. So that's a amazing LangChain timeline. The growth you can see, it's very visible. And yeah, I mean, it's amazing to see their valuation just a year and a half or something like that, reaching 200 million valuation, right? I got it from dealroom.pro. And I was recently searching for some reports around LangChain, and this is what I found. Right, most of you guys know Udemy, and Udemy recently released their 2025 global learning and skills trends report. And as I can see, this is one of the LangChain is the fastest growing skill topic, technical topic under AI, right? As you can see, the growth rate is almost 4,000%, right? 3,949%. Very amazing to see that. And again, through technologies like ChatGPT and LangChain, generative AI transforming how businesses automate and enhance multiple processes using advanced conversational agents and content generation. Here again, top 10 consumed skills in artificial intelligence. LangChain comes in on the third position. This is again from Udemy's recent report. So, yeah, let's understand where exactly LangChain sits in the generative AI dev stack. If you are building a generative AI application, where does the LangChain sits in, right? So I have basically divided the whole Gen AI dev stack into five layers. That is UI layer, service or chain layer, the model layer, the storage layer, and the infrastructure layer. Infrastructure layer is the three big guys: Azure, AWS, Google Cloud, and we also have NVIDIA that gives you a lot of GPUs and infrastructure. And then the storage layer, that's where all your database, specialized databases, Pinecone, Single Store, VV8, ChromaDB, Quadrant comes in. They sit there. And then the model layer is any large language models from OpenAI, Mistral, from Hugging Face, and all that, Cloud. And then the service or chain layer, that's where LangChain, Llama Index, and Haystack AI frameworks sit in. That's where LangChain comes in. And the UI layer can be anything from React to that you like, right? And yeah, this is again the other way of looking at it, the generative AI technology stack, if you're more of a developer focused guy. The front end hosting, as you can see, there is Vercel, Netlify, Streamlit, and then the runtime or framework, that is where LangChain, Llama Index, Haystack, all these things come together, sit there. And then in the vector databases layer, there is Pinecone, VV8, single store. There are a lot of choices out there. And then the foundation models we saw, right? And then the infrastructure layer, the NVIDIA, AWS, Together AI, and Google Cloud, all these things that give you the infrastructure to basically build robust AI applications. And then let's understand the principles of LangChain. What LangChain stands for, why companies are actually should be using LangChain, right? To basically access the other data that is personal, that is custom data, such as enterprise or developer owned data, documentation, various open source data sets, etc. Right? So this data awareness is the first principle by LangChain. And then the second principle is to interact with other tools, APIs, tools, tool calling, right? Python compilers, math calculators, examples. So this agentic behavior is the second principle of LangChain. That's why most of the companies basically use LangChain, right? And these are some of the advantages of LangChain. Modularity, you can basically LangChain breaks down the LLM component applications into reusable components, right? Making it easier to build, maintain, and scale applications. And then the flexibility. LangChain supports wide range of LLMs, open source, closed source. It is basically model agnostic. And integration. LangChain has seamless integration with a lot of vector stores, a lot of popular Python libraries, and Hugging Face transformers, and Streamlit, Vercel, etc. And then extensibility. Developers like extensibility, and they can create custom components to extend the functionality of LangChain and tailor it to their specific requirements, right? And then the faster development, improved quality are the other two things that come as advantages of using LangChain. And what are some of the use cases? Why people are using LangChain for to build what, right? Basically, to create chatbots, to create agents, right? Interact with APIs, to do code understanding, to for querying tabular data, and then the for valuation and for extraction, and then question answering using documents as context, and then the summarization part. So text summarization and all that. So these are some of the basic use cases of LangChain, right? And then comes the reasons to use LangChain. Why you should be using LangChain? It's again the similar to the advantages of LangChain, right? The modular design, flexible component integration, and you can reuse the components. The prompt management, you can efficiently handle the prompts and templates. Model agnostic, you can use open source, closed source model. There is no restriction on that. And then it has good memory management, and then the chain composition, you can basically build complex workflows using LangChain. And then the agentic framework, right? You can build autonomous AI agents. You can build robust AI applications using the agentic framework from LangChain. And then the tool integration. It has a good integration with many tools, APIs, and then the evaluation part, right? And then how LangChain basically enriches your Gen AI applications is like, all these components that we discussed, prompt templates, chains, agents, tools, memory, all these, and the LLMs, they sit in between, and then to help you basically get the enhanced output, or enhanced AI responses, whether you are building text summarization, application, or you're building chatbot application or anything. So it basically help you get the enhanced AI responses, contextually relevant AI responses. And then let's take a simple example, right? Building AI apps using LangChain. A practical example is here. If you ask this whole system, right? When is Thanksgiving in the United States? So the query goes through the chatbot agent, and the chatbot agent basically has two parts, that is parsing and the prompt template. And then here the prompt template will decide how to handle this query, and it basically divides the query into two parts. As you can see in the next step, that is chain. The two steps are like, what is the holiday name? It goes through the web to find the holiday name, that is Thanksgiving, and then then comes the retriever with the question, when is it celebrated, right? It goes through the vector store to find when it is celebrated, right? And now we have the answer for both the questions. And at the end, it goes to an LLM model to basically formulate the final answer saying, hey, Thursday 28th number is the Thanksgiving in the United States, right? By the way, this is 20, for 2024, right? And then getting started with LangChain is kind of very easy. I'm more of a Python guy, so I use pip install LangChain. And if you want to use third-party integrations, you can use LangChain community, pip install LangChain community, and these are some of the libraries. LangChain core is the all the stable libraries, and then if you want to use the other models from OpenAI, you can use LangChain OpenAI. If you want to use uh, LLM models from Anthropic, you can use LangChain on Anthropic. And then there is LangChain community for all the third-party integrations that are community maintained, right? And then since our tutorial is all about retrieval augmented generation, RAG, so let me explain what exactly is RAG, right? So what happens basically, these large language models basically they hallucinate. What do you mean by hallucinating, right? If you ask the LLM model a recent question, query, something what happened yesterday, anything for that matter, right? So sometimes it might answer some fake answers. It might come up with a made up answer or incorrect answer, but you might think, hey, that might be the right answer. But you don't verify that. So this behavior of large language models is known as hallucinating behavior, right? Factually incorrect, nonsensical, or completely unrelated responses, right? So to mitigate this hallucinating behavior of large language models, we basically have three approaches. One is fine tuning, the second one is prompt engineering, and the third one is what we are talking now. It is RAG. Prompt engineering is basically nothing but the art and science of using different type of prompts, right? Working with your prompts, the query, and seeing the outputs. And then the fine tuning is where you get a base model. You fine tune that base model with your custom data so that the model can easily understand your vocabulary, your grammar, that best fits your your what do you call your company, right? Then you can basically use that LLM for your requirements. And then comes the RAG, right? Retrieval augmented generation, where you basically use an external knowledge source like a database to basically feed that database with all the relevant information so that the LLM can easily fetch the responses from there if it doesn't know anything. That's how you basically mitigate the LLM hallucination behavior. And RAG by far is one of the most effective approaches when it comes to mitigating the LLM hallucinating behavior. So this allows RAG models to provide more accurate, contextually relevant responses back to the user, right? And as you can see in this image, right, if you ask a question, who won the 2024 Nobel Prize in Literature, the pre-trained LLMs will come back and answer saying, hey, as of my last update, I can't provide you the information on who won the 2024 Nobel Prize in Literature because there is a cutoff date for all these LLMs, right? It can be 2023 and all that. So they can only answer up to that range. After that, they feel like they start hallucinating. because since they are trained with large amount of data sets. And then with the external database, with all the information, access to Google search and web search and all that, with RAG, if you ask the same query, who won the 2024 Nobel Prize in Literature? Now with RAG, you have the answer. Right? The winner of the 2024 Nobel Prize Literature is Khan Khan. So that's how important the approach of RAG while building AI applications. Okay. So how does LangChain help in RAG? So at different stages, LangChain provides the necessary tools in the RAG approach for a RAG application. As you can see, the first line above, right? The document processing pipeline. You have a document, it gets split, and then vector embeddings are created, and all these vector embeddings are stored in a vector store. And then when a user query comes in, it goes to the vector store to fetch the relevant chunks and through the retriever, and then it goes through the LLM model to finally respond back to the user. So at each stage of this whole RAG pipeline, LangChain has the modules and the tools to help you build robust RAG or AI applications. Right? There are document loaders, there are text splitters, there are vector store integration, right? There are embedding models, all these things, and there are LLMs that you can use. Yeah, I mean, what happens if you don't have, if you don't use without LangChain, if you don't use LangChain, right? So LLM application development workflow with and without LangChain. So as you can see on the left-hand side, right? Your developers had to they have to hard code everything. They have to write all the code even for simple things like custom API authentication, rate limiting logic, custom prompt template. So all these things can be easily managed using LangChain, right? Simplify all these things are simplified with LangChain. Built-in authentication handling, integrated rate limiting. There are prompt templates, vector store integration, document loaders, memory components. All these things are easily managed using LangChain. So your developers have not to, you know, they don't have to worry about much about how to build AI applications now. Now, since we have LangChain, it's very easy, right? So this is a simple demo that I'm going to show today, right? RAG, Retrieval Augmented Generation with Single Store. I have a PDF file that gets split. We're going to chunk that and then create vector embeddings. And then all these vector embeddings are stored in a database, a vector database like single store database. And then for a user query, when a user query comes in, even that gets converted into a vector embedding, and it goes through the vector database to find the relevant chunks or matching documents. And at the end, it goes through the LLM model to finally respond back to the user. So we have a simple use case here, and I'm going to show that through a simple tutorial, right? So let's see how this works using a tutorial, right? Let's move to the tutorial part. Hey guys, so here's this basic LangChain tutorial. First things first, we're gonna install LangChain and all the required libraries. LangChain community, OpenAI because we're gonna use OpenAI model. And then we're gonna mention our OpenAI API key. And then understanding the prompt templates. Prompt templates are a key concept in LangChain. They allow you to create reusable prompts with variable inputs, making it easy to generate dynamic content. Right. So we import prompt template and then this is a simple example, right? What is the capital of France? It will answer. We're just testing the LLM here. Now comes the prompt template, right? From LangChain import prompt template, and then as you can see the prompt template. Tell me adjective joke about topic. So you can basically fill in these two instead of using the giving the query again and again, right? The input variables are adjective and the topic. So if you say adjective is funny and the topic is programming, the our prompt template finally is like tell me a funny joke about programming. So that's how you can basically build the prompt templates and work it with LLM models. LangChain supports various LLM models. So this slide basically demonstrates how to use different models and adjust their parameters. So you can adjust. We are using OpenAI model from Hugging Face, and then temperature. You can basically set the maximum tokens, and you right. We have set the temperature and the maximum length tokens here, right? And then you basically add your Hugging Face Hugging Face API key, API token key, and then the prompt is explain the concept of artificial intelligence in simple terms. And as you can see, the AI response, OpenAI response, right? So this is the response we received. This is how you can use different open LLM models to basically build your AI applications. And then the chains in LangChain, chains are a fundamental concept in LangChain, allowing you to combine multiple components to create more complex workflows. Right here, we are basically asking create a catchy slogan for the company name. Right, suggest a name for a company that makes this product. So there is a prompt template we are creating, right? And then this is getting combined with the LLM model. And then if we ask to generate that, it will be like company name. The company name is Intelli Home Tech, and then the slogan is Smart Solution for Your Modern Home. So you can basically combine your prompt template with LLMs to basically create complex workflows. So to solve such problems, right? That's how we saw here, right? And then the memory in LangChain. LangChain provides memory components to maintain context across multiple interactions. This basically explores how to implement and use memory in your applications, right? So the first input from my side is, hi, my name is Alice. What's your name? This is the second, what's my name? This is the second query. And then the third query is, what have we talked about so far? So if you see, it will start, the LangChain system starts executing the things one by one, the finished chain, right? Hello, Alice. Alice, it's nice to meet you. My name is AI, and I'm an artificial intelligence program to assist and communicate with humans. How can I help you? Right. And then the second one is we asked basically, what's my name? So it remembers, right? Your name is Alice. I remember it from when you introduced yourself earlier. Is there anything else you would like to know? And then the third query we asked was, what have we talked about so far? So as you can see, the last one, so far, we have talked about your name and how I am programmed to assist and communicate with humans. So this is what it knows what we talked about and all the chat history. So that's how you can use LangChain, right? Yeah, this is again the same thing. And then you can basically combine agents to build agentic applications, and then the tool calling to build your AI applications. The tools that we are using here is Wikipedia and the LLM map, and then we are initializing with a zero shot React description. And then if we ask the query, what is the square root of the year Pythagoras was born? Right? It goes entering the new agent executor chain. It starts executing this autonomously, right, by itself. So it says I should use the calculator tool to find the square root. So since we are using LLM math thing here, and then it uses the calculator and then finds the output, and then says like I should round the answer to the nearest whole number. Action calculator, it does that, and then yeah, I mean, you basically get an idea, right? It basically autonomously starts executing using the like using the agents and the tools that we specified to. Right. So yeah, this is how you can basically use LangChain with all the models to build your AI applications. I'm going to share this link in the description so that you can go ahead and try that. Thanks. Yeah, so here we get to the main tutorial, that is building RAG systems and applications using LangChain. And here I'm using single store as my vector database so that I can feed in all my vector embeddings into this database, right? So you can use a single store also. Single store has a free share tier. You can go to singlestore.com, sign up, and then once you sign up and sign in, this is where you will land. You will have the workspace ready. If you don't have a workspace, create one just by clicking create workspace and attaching to your workspace, create a database. So creating a database is also very easy. My database is already ready. I have created a database by the name LangChain. And then one interesting thing about single stories, they provide an integrated notebook kind of environment where you can create numerous notebooks, right? So create a new notebook, give it a name, make it shared or personal, give it a name, and then create one. And yeah, this is my notebook with all the code here. I'm going to explain step by step. So first things first, make sure uh, you attach your workspace here and mention your database where you want to store your vector embeddings, right? So I'm using LangChain and single store. So we install the libraries and the dependencies. I'm going to basically installing LangChain, single store, and all the required libraries and importing the libraries, right? That's what I'm doing. And then we are going to load our custom document. So I have a custom document, a PDF file that talks about some economical reforms and all that, right? So this is what I'm loading. And then I'm splitting the document into chunks using your LangChain's recursive character text splitter. Okay. And then once I split that, I'm going to receive the response saying you have 178 documents in your data. There are 44 characters in your document. You have 379 pages, right? That's how big our document is. And now we're going to use OpenAI API to generate embeddings for the document chunks, right? Now we did split the document. Now let's create vector embeddings, right? For that, we're going to use OpenAI embedding, OpenAI model. So after that, let's store our document embeddings into single store database, right? So that's how we're gonna import OpenAI embeddings, and we're going to mention from LangChain vector stores import single store DB, and then we're basically creating a table name PDF UN underscore UN. So under the LangChain database, we are going to create a table name to store our vector embeddings. Okay. And then let us check the text chunks and associated embeddings stored in our database, right? So this is a simple, this is how it is stored, right? If you go and see, this is how it will be stored. I'm going to show you how the vector embeddings are stored in our database. And now everything is stored. We did split our document into chunks and the vector embeddings are created and all these vector embeddings are stored in our vector database, right? Now let's ask a query against our custom data, just using similarity search to retrieve the top K closest content. So the document basically has something about India's GDP growth. So let's ask such query. What India's GDP growth is projected to be? If you ask a query like this with just a similarity search, we're going to get an answer, a very big answer, right? It's not very accurate, but it is from the document itself. It is retrieving, fetching the content, relevant content from the document. But that is using similarity search. What if we augment, right? Here is the augmented response to the user query, right? Using LangChain. I'm using model GPT 3.5 Turbo, and you can change that. So if you ask the same query here, right? India's GDP growth, as you can see the answer, right? The proper accurate answer. India's GDP growth rate is projected to moderate to 5.8% in 2023 from an estimated 6.4% in 2022. So yeah, that PDF file has the answer something like this exactly. So we got accurate answer here, contextually relevant response. So let's test when the knowledge base is not provided. The custom document that we provided, if it's not provided, what will be the answer with just LM from the LangChain, right? With setting a temperature of zero point 0.8. So if you ask what India's GDP growth is projected to be in 2024, so it will be like it'll it'll answer something right from somewhere. According to the International Monetary Fund, India's GDP growth is projected to be 6.3% in 2024. So this is not present in the PDF, so it is answering something. It's kind of might be hallucinating. It might be answering properly from the international whatever is mentioned in the International Monetary Fund, but we wanted a response from the PDF that we loaded, custom document that we loaded, right? So this is the answer, proper answer, right? And sometimes it will answer like, I, for your question, I don't have an answer since my cutoff date is this. So that's how you can basically build contextually relevant responses, RAG applications using LangChain and single store. And let me show you how the vector embeddings are stored in our database. So we created let's go to deployments, databases. So our database is the name LangChain, then PDF UN was our table that we created. And let's go to sample data. If you see sample data, this is how the all the content of the PDF is stored using this is the vector representation of for this particular content. There is an ID, there is a content vector. So this is how it is stored. And this is a metadata. Right. So hope you understood how to build RAG applications using single store. Thanks.